Hello, Mount Holyoke Psychology 201 students. Welcome to your pre-work tutorial on independent and paired samples t-tests. This is your lab instructor, Natasha. Today, I will be showing you how to run and interpret paired and independent samples t-tests using SPSS. So let's pretend that I noticed that there seemed to be more students drinking water during my afternoon lab sessions than in the morning. And I wanted to see if students in the afternoon lab sessions drank significantly more water during lab than the students in my morning sessions. What kind of t-test would I need to use? It would be an independent samples, right? Because we have two separate groups of students that we're looking at. So to run an independent samples t-test in SPSS, first I'm going to show you just the first two variables that we have in this data set. The first one is the time of lab. So we see here whether students are in the morning section or in an afternoon section. And then the second variable is water consumed. So let's say this is the ounces of water that each student reported consuming during their lab session. So what we need to do is go up to Analyze, down to Compare Means, and over to Independent Samples t-test. Now you'll see a couple places where you could put some variables. The variable that we're actually going to be testing is the water consumed. So we're going to put that into the test variables box. Then there's this other box here called grouping variable. This is how we're going to define the different groups that we're comparing. So we're going to look at the time that students are in the lab. Now you'll see that we can't just hit OK yet, because what SPSS needs to know is how we want to group the variables. So we need to define the groups. In this case, you can see, actually, if I cancel out of here, you'll be able to see by hitting this value labels button that AM and PM were represented by ones and zeros. Okay, so let's go back into Compare Means, Independent Samples. Again, we'll move the water consumed over into the test variables box and the time of lab into the grouping variable. Now we're going to define the groups based on zeros and ones because that's how it was set up. Okay, so for group 1, we'll put a 0. For group 2, we'll put a 1 and hit continue. Now we can go ahead and click OK. And you'll see that this is the output that we get. And this is a very long table for the independent samples test, as you can see. The first table, though, is the group statistics table. It tells us how many students were in each lab section. So there was 20 students that were in morning sessions of lab and 20 that were in afternoon. And this gives us the mean ounces of water that they reported consuming during their lab periods. So for the AM students, they reported an average of 4.1 ounces of water, and the PM students reported an average of 6.65. This is the standard deviation and the standard error of the mean. So how do we interpret this big table at the bottom? This is the independent samples test. We're going to treat this first section, the Levene's test for equality of variances, as its own thing before we move into the actual t-test. What this is doing is checking to see, one of the assumptions of running an independent samples t-test is that the variances of the two samples will be similar. And so you need to test to make sure that they are similar before we can figure out what formula to use for the independent samples test, whether we can use the formula you learned in your lecture or whether you have to do some other calculation to account for differences in variances. So again, it's assuming that the variances of the two groups look something like this, sort of similar. If, for instance, the variance in one group looked something like this, and in the other group it was more spread out, this would violate an assumption of an independent samples t-test that they were similar. So that's when SPSS would run a different calculation for you. In this case, you can look under the SIG column and you see that it's above 0.05. So that means that there's no significant difference in variances between the groups, which is what we're hoping for. So we can use this top line of data to read our results. Okay? So now that we know that, because it says equal variance is assumed, we can look that here is our t-value, here are our degrees of freedom, and you can see that they're calculated the same way that you would have learned in class. It's adding the two ends and subtracting by the number of groups. So we have 40 minus 2, which is 38. You can see the degrees of freedom are slightly different, were the variances to be different, significantly different from each other. But again, we're using this top line of data. So here's our t-value, our degrees of freedom, and our p-value, our significance. So assuming a 0.05 alpha level, if you remember, the actual research question was wanting to see if there was significantly more water consumed during the PM sections. So what we have to do, since this is a two-tailed, is divide this number by 2, right? So we get a p-value of 0.015. So then we can say, when we're interpreting it, that the afternoon classes actually do drink significantly more than their peers in the AM classes. So again, the 6.65 ounces is a significant more amount than the 4.1 ounces. Okay, so that's an independent samples test. Now let's say we're going to work with a paired samples test as well, right? So let's say I was daydreaming about Bunny Day, which is when Jenny, a lab instructor from the biology department, brings her baby bunnies to the Reese lobby. And I wondered if students would feel a different level of relaxation after looking at or holding, or, okay, let's get real, just being in the general vicinity of these bunnies. I mean, look at them. Okay, so this would be a paired samples test because we're looking at the same students before and after they were with the bunnies, right? So we have the variable of stress pre-bunny and stress post-bunny. So to run a paired samples test, you go to Analyze, down to Compared Means, and then this time over to Paired Samples t-test. And you'll see we're looking at a pair, there's 2 variables we want to compare. In this case, we're looking at the stress before the bunny and the stress levels after the bunny. And that's all you have to enter before you hit OK. Now you'll see in your output, there's some different columns. This paired samples correlations is not an important table to look at. This first one gives us the mean and the end, so this is important to look at. So this is saying that the average level of stress, and I forgot to tell you, this would be on a scale from 1 to 5, with 5 being more stressed, 1 being less stressed. The stress level reported by all the students before holding the bunny was 3.55, and the stress after being around the bunnies was 1.98. So to see whether this is significantly different, we'd go now down to the paired samples test, and we'll see that the t-value is here, 6.356. Degrees of freedom are here, which is 39. And the significance is 0.000, which is less than 0.05. So you can say that the difference between the 1.98 and the 3.55 is significantly different. And because this is lower afterwards, you can say that students were significantly less stressed after being around the baby bunnies, which makes a lot of sense, right? So that's how to run a paired samples and an independent samples t-test in SPSS. And until next time, remember, don't be mean, be above average.